Say again? Graphicals. Yeah, we're looking at some graphicals. Meaning we're looking at graphs, examples of them. Alright, so let's start with the easiest one here, conversions. Let's do a quick example of conversions. So, come on, focus, guys. Okay? So let's look at this first one here.
There seems to be a malfunction. No, the other way. Why is that? No.
Why? What's the difference?
Yeah. Yeah. There you go. Bad for your eyes. They're fluorescent. Yeah.
Like that?
They probably only have those. I was like, what is that? Yeah. I was like, Chelsea, I go to cow tipping on a daily basis.
Cream?
Okay.
Thank you. All right.
I just had a little throw up.
Oh, that's kind of gross. All right.
It was cute.
95 kilometers per hour. That's how we start always. Remember, whatever your units are, write it as a fraction. After that, we have to think about the fact that we need to go from kilometers to meters, and we also have to go from hours all the way to seconds. So we have options here. Chaz, give me your starting point for this one.
So we can start with converting hours to minutes.
Okay. So get rid of hours to minutes. How do I do that?
Hours on top, so 1 hour and then 60 on the bottom.
Because there's 60 minutes in an hour.
And then you cross cancel the hour. And then you put 1 minute on the top on the next one, and 60 seconds on the bottom.
Okay, again, he's doing this on purpose. He sees hours is in the bottom, so he puts it up top to cancel. He saw that minutes were now in the bottom, so he put minute up top to cancel. And the conversion is correct. There are 60 minutes in an hour. There are 60 seconds in a minute. Okay, those are our conversion factors. That's what they're called again. Now, that gets rid of hours to seconds, but we want to get rid of kilometers and turn it into meters. Helen, how many meters in a kilometer? 1,000. Very good. So
you do times 1 meter over 1,000 kilometers.
you sure?
Oh no.
Is 1,000 kilometers in a meter?
Oh no. Other way.
Yeah, okay. Be careful there, okay?
Yes.
Again, it's all right. There's 1,000 meters in a kilometer. And remember I taught you guys about prefixes. Kilo means 1,000. So by doing this, watch what happens. I would read the top as 1,000 meters. The bottom, I could read that as 1,000 meters, technically. Because kilo means 1,000. So this literally says 1,000 meters. Let me point so you can see. This means 1,000 meters, which is the same thing as 1,000 meters. Okay? Cancel kilometers, and you have meters per second. So your final answer is the product. So it's going to be 95,000 over 3,600 when I multiply the denominators and multiply the numerators. Units of meters per second. And we should really get an answer for this. Okay, so we would divide the numerator 60 times 60. So we have 1 hour, 60 minutes, 60 seconds, 1 kilometer. Just look at the numbers along the whole bottom. So 60 times 60 is 3,600. And then 95 times 1,000 is 95,000. Okay? We would actually have to divide these two now to figure out. Yeah, I saw.
Do you have a dickie?
We'd have to divide these two. What do we get?
Got a dickie.
Relax, relax, relax.
That's what they're called.
I know that's what they're called, but you're saying it another way and trying to emphasize things. Can we,
He said that's the most annoying thing.
Oh yeah.
It's one of my big pet peeves.
What?
When people say other things, they mean one thing, and you clearly know what they mean. So divide these two, you get a number. All right? Let's take a look at the next example.
Wait, what's the on the side?
I don't know. You guys have calculators. Figure it out. Right?
Why are you angry today?
Let's look at a graph now. Let's say we have a graph of velocity versus time. And we're told on the graph that the graph is increasing at first, then it's flatlined, then it's decreasing, then it's increasing, then it's flatline again. Okay? So we have First, increasing velocity. Then we have
Decreasing
a
velocity.
flat line, which is constant velocity.
Then decreasing.
Then,
almost constant again.
well, then increasing, and then almost constant at the end. Let's make some statements here, please. Let's call this 2 seconds. Let's call this 3, 4 seconds. Make that 5 seconds over there. I know it's not linear, okay? Now, and I'm going to ask the question you have to answer. From 0 to 2 seconds, what can you say about the acceleration of the object? From 0 to 2 seconds. The acceleration. I didn't ask about the velocity. The velocity increases, for sure. The velocity goes up.
It's starting from rest, right? So the acceleration
No, this is not, rest is 0, down here.
Oh, well, the acceleration is constant.
Okay, and what is it? Is it positive or is it negative? Why?
It's going forward. It's going up.
Because the velocity is increasing. Let's make a statement here. From 0 to 2 seconds, the acceleration is positive because the velocity is increasing. Again, from 0 to 2 seconds, it's obvious from this graph that the velocity is going up. I mean, just look at it. Follow the path. It's going up, the velocity. When the velocity goes up, that means your acceleration has got to be positive. Okay, it's got to be positive. Cream, second part. From 2 to 3 seconds. What do you know about the velocity here, Cream? So what is the acceleration if the velocity doesn't change?
0.
Oh, no, it is 0.
It is a constant, but it happens to be a constant known as 0. Good. So from 2 to 3 seconds, there is no acceleration because the velocity is constant. Because the velocity is constant. Okay? Erica.
So something's, if velocity or so if velocity is constant, it doesn't have an acceleration, so it's going to be 0.
Unless it's circular motion, like we just studied. That's the only time.
I mean like this.
Yes.
Do those alternate the statements? Can you flip that around? Like so?
Other tissues.
If acceleration is
Can I blow my nose outside?
Yeah, right.
You could flip the first statement around, which we're going to do from 3 to 4 now. From 3 to 4, the velocity is decreasing, so the acceleration won't be positive anymore.
No, it'll be negative.
Yeah. Okay.
Can I blow my nose outside?
So, from 3 to 4 seconds, as we said, from 3 to 4, hold on, Helen. We see that the velocity is going down. Okay, the velocity is going down. When the velocity decreases, the acceleration, everybody is? Or? Negative, let's just say. The acceleration is negative because the velocity is decreasing. Okay? And that's all we'll do for this one. We'll leave the other parts alone. The other parts are similar answers. Actually, let's say from this point, though. From 5 on here, see how the velocity is kind of fluctuating? It's kind of moving up and down a little bit here along this line. Since the velocity is fluctuating, we could say that the acceleration is also fluctuating. Okay? Another good point to make, actually, is this. If you ever have a positive velocity and then a negative velocity, the person or object must have done what?
Had no displacement.
Say again? No, Nicole, what were you saying for?
Like go back to the same spot. Like you go
Not necessarily the same spot, but go to the same
Direction.
direction. Okay, we don't know where they go. Again, if there's a positive velocity, focus on it. If there's a positive velocity and then there's a negative velocity, the object must have changed direction at some point. Okay? Again, when you see a change in the sign for velocity, there's a change in the direction of the motion. Okay? All right. Let's look at an example of projection. So let's say we have a cliff. Oh, sorry, Helen, I didn't take your question. Go ahead.
Did we ever do an acceleration times time graph?
An acceleration versus
Did we
time.
do anything other than velocity times time?
We did distance versus time, or displacement versus time.
So the distance was just like so straight up, doesn't out.
If the distance was increasing, the velocity was positive. If the displacement was decreasing, the velocity was negative. It's the same answers as this, except you go from displacement to velocity instead of velocity to acceleration. Okay? And that, what you learned right there, what you understood, is called the derivative in calculus. That's what the term means. Okay, the derivative of a displacement is velocity, whereas velocity is acceleration. That's that whole idea that we're going through. Okay? All right. Example. An object.
What is this?
Projectile motion. Two-dimensional projectile motion. So we're going to look at cosines and sines and cliffs and displacements. Okay? Guarantee this is a big part of your test. An object travels from ground level to a cliff of height 50 meters. If the launch angle is 30 degrees and the time it takes is the time it takes to reach the cliff height or to reach the cliff is 5 seconds. Find, God bless you.
There's a lot of flirtation going on.
Find the
Kind of distracting.
Alicia's like, yeah.
Find the initial velocity and horizontal displacement. This is an example of one of your free response questions. Okay? So you're going to have, and I'll go over the whole format tomorrow of everything, but you're going to have multiple choice as always, short answer, and free response. This would be like a free response. The free response are worth 8 points each. Okay? So the big chunk of your test. There are 8, you will choose 5. Okay? You can choose to omit 3 of them. So if there's a specific topic that you have trouble with and you get to the test and you want to omit it, you omit it.
So we'll give us like 8.
I'll give you 8 problems total and I'll say just answer 5, write omit on 3 of them.
And then it's free response.
That's free response. The short answer is normal. You have to do them all. Multiple choice, do them all. But again, tomorrow I'll go over the whole format. I'm going to wait until then. All right, so what do we do to help us with these kinds of problems to start?
FBG.
No, just
Write down the given.
Draw something. Yeah. FBD is when there's forces, remember? Free body diagram. Let's just draw a picture. Okay?
Write down the given.
We'll use the givens as well.
how about you write down the
The theorem or postulate.
supplementary
This is a vertical.
Alright, so here's the ground and there's a cliff.
horizontal cliff.
Stop, guys. The object is launched at an angle of 30 degrees with some initial velocity up to a cliff height of 50 meters. Okay?
Yes, I had to type it.
So this is our problem here. We are told that it takes 5 seconds to travel this distance. Okay, we're told it takes 5 seconds. We're asked to find the horizontal displacement. What variable is that? X.
Project X.
Good. Just raise your hand. Very good. What is the 50 meters? What variable is that?
Plane.
Not D, but Y. Be careful there.
I'm a little rusty.
Okay. Happens to the best of us. Now, we're trying to figure out the initial velocity, so let's put a question mark here. Thank you.
No one touched that hand.
I sneezed under my... In the pocket. In the pocket. Seal it up. You know you're supposed to sneeze like this, right?
Yes.
Into your armpit. I tried to, but it didn't really work. I would have dropped this. It was... Yeah, there's a ton in there. You want to see? Now,
my pocket.
Let's start with our x and y direction. Okay? From this diagram alone, God bless you. From the diagram alone, focus people, come on. From the diagram alone, we can write this out. We don't even need the problem anymore. Okay?
So we're looking on the midterm. Are you gonna grade us if we do diagrams? Like if I hate doing diagrams.
If your givens and stuff are wrong, you don't have a diagram, you're probably not going to get any credit. But if you have a diagram and it's right, and then you make a little mistake along the way, you might get some partial credit.
Oh, got it.
So you got to bank on getting it all right then. That's fine with me. You do that. So in the x direction, we are looking for the displacement. We don't know it.
Wait, would y be the VI?
Would y? No. Y is not the VI. We're going to talk about what that is in a minute.
It's 50.
In the y direction, it's 50. Very good. Okay, that's what we know so far. Now, question for you, and you'll see this on your test. Before we go any further with this problem, answer these questions. If the object had been launched from the cliff to the ground, what's y? What is it? Negative 50, because you started the cliff, and remember y is really delta y. It goes down, shot downward, negative. Dropped. Next, what if I were a field goal punt or a football player and I was the punter and I punt the ball down the field? It starts at ground level, it lands at ground level. What's y now? Zero. Again, if an object is launched and it starts here and it still ends here at the same height, so I could run across the room and jump and then land here, my delta y is 0 because I started at the ground and I ended at the ground. Okay, make sure you know both of those, please. Okay, they're both going to come up in different problems, but you need to know that. Erica.
What was the difference like with that? Didn't there have to be like another factor? Because like everyone was confusing it. They were saying like
That's theta.
not displacement, right? Like would the displacement be different?
I don't know what you're asking right now, to be honest.
Okay, with the ball being punched, it started at ground level, ended at ground level. Displacement is 0, right?
Correct. Vertical displacement. Horizontal displacement is x.
Okay, that's what I'm saying. Like you measure it.
Correct. You measure that.
But then with okay.
But delta y is 0.
Okay.
All right, let's keep going. The time taken was given as 5 seconds, and that's on both sides.
Linking variable.
Okay, very good. Thank you. That's what I was going to ask. Time is your linking variable always. Please write it on both sides. Next. The tough part that we're going to notice here is this VI portion. And that's the issue here. And that's why this is tough, because it's two-dimensional. The object is not launched straight up. It's not dropped from rest straight down. It's not kicked horizontally, but it's launched at an angle theta. Okay, at an angle theta. So we have to remember that not only do we have VIX, but we also have VIY. And this is where our sines and cosines come into play. Who remembers raising their hand about x and y and sine and cosine and how they correlate?
Cosines for x and sines for y.
Very good. And how do you do? Is there a specific way to memorize it? Or you just have it, you know it. Okay, you just know it.
X comes before y, C comes before
If you ever
x.
forget, think alphabetical also. That works too. But if you just remember, that's perfect. So here, VIX is VI cos theta. VIY is VI sine theta. But remember, for this problem, our goal is to determine the values of x and VI. So what we're really looking for, and I'm going to point it out, we're looking for this variable for sure, but we're looking for this part now, and this part, the VI portion. We're not looking for VIX or VIY, we are specifically looking for just VI.
Do we have a final velocity given?
We don't, so we can't do anything with that, and that's a good point to make. In the other class, somebody said, well, why isn't the final velocity 0 if it lands on the cliff? Well, technically, the cliff is comforting it or letting it land on it, so there would be impulse there. So we don't know what the final velocity really is. But we do know something about Earth. and something about that holds us to Earth.
Gravity.
Yes. Acceleration due to gravity. In the y direction, what is it always? Negative 9.81 meters squared. We can't forget that acceleration is seconds squared. Not just, that's why I'm emphasizing that. So many of you on the last test lost points for units. Please, please. What is the acceleration in the x direction?
0.
Good.
How do you know?
Because we are not including air resistance with these problems. Remember, if there was air resistance, it would be slowing it down, so it would be like a negative acceleration. So we've got all of our info. Now watch what I'm going to do. I'm going to then get rid of the diagram, because now I don't need that. Now I can just look at this. So see how we're going from word problem to diagram to our givens. From our givens, we'll then work on our equations. And a question or statement? All right, let's go.
Would
Do
you
it.
do y equals vi yt plus 1/2 et squared?
Very good. Now, Emmett knows to do this because in this case, we notice that we have y, we have the time, we have the acceleration. We're looking for vi. Does everybody see that? We are looking for vi. Okay, t squared. Thank you. See, good thing. Good thing. And you know what? One thing that I did notice is that on some of the tests, people forget the squared. I just happen to forget writing it. Your formula sheet will be given, but remember this, people. Remember on your formula sheet, it does not look like that. And I'm going to write at the top, please. So write this on the side. I'm going to write it up at the top corner. This is what you're given on your formula sheet. But you need to adapt that formula into terms of y. So instead of x, you put a y. Instead of vi, you put viy. Instead of a, you put ay. And all that means is that we're looking in the y direction now. Okay? It's the same formula, but you're adapting it. Now, look at this equation. You've got everything except for viy. You've got everything except for viy. So all you need to do is solve at this point. Over here, though, let's look at the x direction before we go any further. Remember, for all projectiles, there's no acceleration in the x. So we don't have to use this long equation. We can just use velocity equals displacement over time. And remember, this is the velocity in the x. Okay, this is the equation that we're going to use. Now, in this equation, here's what you're going to notice. Vx is this right here. Vx is this. So we have one unknown variable vi, and t is also unknown. So we cannot do anything with the x direction right now, which is why we start in the y direction for this kind of a problem. Again, let me reiterate that. Vx is really vi cosine theta. That comes from up here. Sure, theta is 30, so we know that, but we don't know vi and we don't know x. We know time, we know theta, but we don't know vi and we don't know x. So this is useless as of right now. If we can find the vi in the y direction, we can carry it over here and then solve for the x variable.
So the VI is the same.
Correct, because the vi, remember, was just the initial velocity. The only difference is that this one has a cosine and this one has a sine, but vi itself is the same variable. This is the same as this, exactly. So when you solve for vi over here, remember, look at the y direction, please. This is going to become vi sine theta t plus 1/2 a t squared. Okay, ay t squared. So again, where does the sine come from? Right here. VIY is VI sine theta. So we plug in for VIY right here with VI sine theta. Yeah, at this point, if you want to plug in numbers, that's fine. Okay, you can solve algebraically or plug in numbers. It doesn't matter. Let's go through this.
So that's 50 equals
Go ahead.
So we've got 50 equals VI. The sine of 30 degrees in your calculator is 0.5 or 1/2. So I'm just going to put a 0.5 here. Again, write that down, please. You don't need to memorize it, but just know if your calculator is in the correct mode, make sure your mode is in degrees. your calculator, and you hit mode, should be on degrees. Okay? So when you do the sine of 30, it's going to become 0.5. Times t, when t is what? 5 seconds, right? I don't know why I wrote t, let's just write 5. Now, anybody remember that common number? What's 1/2 of 9.81?
Negative 4.905.
Good, negative 4.905. You don't need to memorize that, but it can prove to be useful at times. Okay, notice at the end here, I just put 25 because it's 5 squared for t squared. Again, 1/2 of the acceleration is negative 4.905. T squared is 5 squared, which is 25. Now, we would solve this equation and get VI. Is that clear so far?
Yeah.
I'm not going to do it. I'm not going to get the number. Okay, you would get some number. Then, you would take that answer, the answer that you end up getting, I'm going to circle it, for VI here, take that, plug it in over there, in the x direction. Okay, did anybody actually get it?
I'll get it in 2 seconds.
Around 69?
69.
Okay, perfect.
69.05.
Now, we multiply that by the cosine of theta. Focus, people. We're just about there.
Fastest class.
And that equals, because it's a short period, we have to go to math now.
Oh my God.
X over 5. Solve that final part for x. Okay? Solve this for x. Tomorrow, please, be ready with questions from 4 and 5. 4 was forces. 5 was energy. In the second period tomorrow, we'll do 6 and 7. If you want to bring yourself like a small snack tomorrow, because we have a double period and we're going to do this 2 periods straight, to keep yourself, focused, do so. As long as it's something that's not going to really, unfocus everybody.